Without further delay, I'd like to introduce today's presenter, Michelle Bustamante, Chief Architect for the iDesign Inc. Michelle, you now have the floor.
Thank you, Sarah. Welcome, everybody. My name is Michelle, and I'll be here to talk to you about contracts today for Windows Communication Foundation. So this is part 2 of a series of 15 that I'll be doing over the next couple of months. A little bit of background on myself. I am an architect with iDesign and a Microsoft Regional Director for San Diego. I do spend quite a lot of time working with WCF. I actually just completed a book called Learning WCF for O'Reilly, and therefore have spent the better part of the last 2 years working with the platform, if not more. So hopefully I'll be able to share a lot of good information with you and help you also with go-forward planning and more advanced topics as well. So if you want to know where the resources are for this webcast, and I'll repeat this at the end, you go to www.thatindigogirl.com. That is my book blog, and all of my code samples are posted there already in C#. And I'm very close to posting my Visual Basic version of the lab code for my book as well, to be followed by the code samples. So you can stay tuned for that. Demos today will be performed in C#. Now, what I'll be doing today is I'm going to talk about specifically how to design your service contracts, and that also includes data contracts, which I'll get into. I've already given an overview in our last webcast last week, which just gave you sort of an idea top to bottom. How do I set up a service? How do I host a service? How do I generate a proxy for a service? And how do I consume it? You'll see some of that repeated in today's example, so hopefully if you missed last week's webcast, then you'll still be able to catch up quickly. I'm going to talk about complex type serialization, something we deal with all distributed systems in order to send messages between clients and services of sorts. I'm going to talk about specifically related to WCF the types of contracts we work with. So that will be service contracts, data contracts, and message contracts. And then during the discussion, I'll touch on the idea of a coding first versus a contract first approach to building your service contracts. Your prerequisites for today are really that you have an understanding of .NET Framework, of course, and a basic understanding of WCF clients and services. If you have not received some sort of basic training, then I think you'll probably still be able to catch up for today. And so let's talk about the agenda. We're going to start with a short discussion about contracts and metadata. And that'll give you sort of that overview I was telling you from the previous webcast, and understanding, how do contracts become part of metadata. And then we'll get into the rest of the details. So let me just start with the basics. When you create a service, you have to host that service before it can be available for consumption. And so as you see in this particular diagram, there is a service type which must implement at least one service contract, so we'll be talking about that. And once you host the service inside a process using the service host type of WCF, you expose either one or more endpoints, and that is where clients will be able to consume the service. So what's important about an endpoint is that it describes the operations available to the service at a particular address. And so when a client goes to consume a service, usually we generate. Okay, so we were talking about how when services are hosted, they expose one or more endpoints, and those endpoints really define maybe one or more operations at a particular address. And when a client consumes a service, what they'll do is they will usually generate a proxy which mimics the metadata of the endpoint, and then essentially has information about how to access that particular address, where the address is, what protocols to use, and which operations are available. And so what you'll end up seeing is that messages can be exchanged between clients and services, assuming that there is understanding of an equivalent endpoint at both sides. And so just to sort of revisit this, I'm going to show a quick demonstration of how clients would generate a proxy from a contract. So I'm going to head over to a quick example. And in this particular example, so once the sharing window comes up, you'll be able to see my Visual Studio environment here. And the screen's just refreshing there. Okay. So what you'll be able to see here is that I've got an administrative contract. So I'm going to open that first. You see I have an iAdmin interface, and it has two operations, Admin 1 and Admin 2. And then I've got a service contract, iService A, and that's got a couple of operations as well. So what you're seeing is that I've got two service contracts with two separate sets of operations. Now, I've got a internal service here where administrative operations would be accessible over TCP only, and where the other operations would be accessible over HTTP for people inside and outside the firewall. And so what we'll see on the implementation of the service is that I've got two contracts implemented on a single service, and the implementations are very simple in this case. I've got operation 1 and 2 on the main service contract, and then I've got operation 1 and 2 for administrative contract. Now the point of this is that a service can have multiple contracts, but in order to expose those operations for administrative or regular use, I do need two endpoints because an endpoint is associated with a single contract. And so what you'll see in the hosting environment here is that my configuration file has several services exposed. I've got a service exposed here with only the Service A contract over HTTP. And then I've got a Service B, because I didn't show you the Service B, but there is another contract. But if we scroll down to the one I was just talking about, Internal Service A, that service has two contracts, an administrative contract available over TCP behind the firewall, and a regular contract called Internal Service A exposed only over HTTP. And both of these endpoints basically make it possible for clients to look at the WSDL contract and see both the administrative and the internal service operations. So what I'm going to do is I'm going to actually just run the host for a moment. And this will allow me to browse to the metadata. So you're going to be able to see what the WSDL contract is that was generated for that particular service. And where we go to browse, in this case, is going to be localhost 8003. Okay, so my service host is running. I'll go over here to the web browser, and I'm going to browse to the metadata at 8003. And what this will do is show me my default page that allows me to browse the WSDL for a particular service because we've enabled metadata and we've enabled HTTP browsing. So this will just generate from scratch the WSDL, which is why it takes a moment. And when I click on the WSDL, it will show us what that contract looks like. Actually, this one in this case is Internal Service B. Internal Service A was at 8002. So I can actually refresh this and it will generate the WSDL for 8002. So those were the two services that we exposed. Now, at the bottom of every WSDL, it will have the service that we just exposed. And the service I was just illustrating to you was Internal Service A. Internal Service A has the administrative over TCP, and you'll see that net TCP endpoint here. And then it's also got another port for HTTP binding at localhost 8002 Internal Service A. That's the address. And what this should tell you is that the WSDL contract can show one or more endpoints, but each of those endpoints will respectively have their own operations. So what you'll see is over the Service A contract, the HTTP endpoint will only show operation 1 and 2. When we look at the administrative, you'll see admin operation 1 and 2 over TCP. This is how clients are able to generate a client-side proxy and understand what are the protocols I need to access each of these sets of operations, because it says not only where the address is, but it also says what are the operations available and what do those messages look like. So what we're going to do is go to my internal client application, and I'm going to add a service reference to both of those. So we'll go first to localhost 8002, and this is going to be Service A. And then I'm also going to go to localhost 8003, and that'll give me the metadata for service B. So we'll go ahead and have a reference here, and 8003, and this is service B. So what was just generated then from those two endpoints are a copy of the service contract. So you'll see I've got an iAdmin and an iService-A generated for Service A. And that's based on the WSDL. And as a result, of course, in my code, I can now generate copies of each of those proxies for Service A and for Service B. And I will be able to invoke operations at the service. So if I build this, then we'll be able to see that. So this will just shut down first the host because I was running. And then it'll rebuild the client with our new proxies. Might need to get rid of a couple of little things here. Wait till it finishes. Carry over from before. And localhost, service A dot iService-A, which is what we want here. And service A dot iAdmin. Service B is my namespace for this guy. And service B also for this guy. The point being that we generated proxies for service A and for service B, and they're inside the namespace as follows. Service A has an iAdmin copy, and it also has an iService-A copy of the operations. Okay? And from there, we generate our proxies and we make calls. So essentially, we're not going to have to go through a demonstration of that. That's sort of a repeat from last week. I'll go ahead and come back to the slides, and then we'll look at some more interesting things. What I wanted you to take away from that little section is really just the following. When we host a service, of course, the service contract frames the number of operations available. And within those service contracts, each operation usually will have complex types involved that we need to serialize. So we're not going to be just passing strings and integers and so forth around. We need a way to serialize other complex types. And that's where data contracts and other serializable types come in. The other thing we may need to do is have greater control over the overall SOAP message, which is an advanced feature that I'll touch on at the end, and that's how message contracts come into play. So these are the types of contracts that we're going to be discussing in the rest of this webcast. So I'm going to move on now, and we'll talk a little bit more about service contracts, but really just some practices that you should look at when you implement a service contract, since we already saw that in the last webcast. When you define a service contract, what you do is you apply the service contract attribute to the interface. You can actually apply it to an interface or a class, but we prefer interface because then you can apply more than one to a service. And for every operation that you would like to be included in that public contract, in that WSDL document, you must apply the operation contract attribute. So that's shown here, right? And here's a simple example without setting up the namespace or any other properties of these attributes. Now, of course, when we apply the service contract attribute to an interface, what we should always provide at least is a meaningful namespace. And I'm showing you the Web Service Platform standard here, whereby we usually use our domain for either the application or maybe for our company, because we know that's unique. And then maybe some other category and a month and a year. And that gives us a way to version contracts because, of course, if you don't make a change more than once in a month, then you can use a new month and a year when you version the contract, which I'll talk about in the next webcast this Wednesday. So putting a namespace is very important. Otherwise, it's tempuri.org, and that will not allow you to disambiguate messages between your services and other people's services. You can also be explicit here and put the name of the actual contract, because this goes into WSDL too. And if a developer were to refactor the name of the actual CLR type, iContent Manager service in this case, then it would actually impact the WSDL document and impact compatibility with clients. So it's sometimes a good idea to actually have a standard in your company, whether or not you're going to just not let people touch these CLR types that are contracts, or if you're going to be explicit here so that you can prevent the potential risk. And usually that depends on the company's desire to, or the size of the company's team and the desire to control that. Now, every service contract has to have at least one operation to be useful, and typically each method you put inside the service contract interface will be an operation contract. After all, that's what it's for. We're not taking a business interface and turning it into a service after all. In fact, I don't recommend that. What you should be doing is defining an explicit contract, an explicit interface that is the service contract with the operations to expose. And so in that, every method would have the operation contract attribute applied. Now, you don't have to provide a name, since the name of the method will be inferred. But again, that whole idea of if you want to be explicit so developers know these are things we do not touch, then what you could do is build in the defaults even, which is save link in this case. And then in terms of action and reply action, that becomes part of the SOAP message. It's usually generated from the namespace, the name of the contract, and then of course the name of the method. And usually this would be save link, and this would be save link response. That's actually a typo there. So that would be generated automatically, but you could be explicit and then developers know, do not touch this, because that would break a client. Now, one last thing that's kind of interesting that you can do with a service contract, besides, of course, decorating with a specific name and namespace and other things for the operation, is you may need to control the name of the XML element that contains your parameters. So in this case, I have a single parameter. It's a link item type, which is a complex type that carries information about a URL link with a title, description, and so on. And that type, the formal name, the CLR type, is link item with capital LI. Now the parameter name is item in lowercase, but I may not want my messages to use lowercase for XML if I'm a stickler for naming convention. So to control what that XML looks like, you can use the message parameter attribute and provide even a proper name like the CLR type name. And that will tell it, when it serializes this message, inside the body of the message, use link item as the proper name of the XML element. Now, why would I care about that? It's going to work either way. Usually the folks that care about these things are folks that are defining schemas to either match some sort of convention that you're using in other schemas, and perhaps because you're doing trading with business partners over web services, you're a bit more close to the XML than most. Generally speaking, of course, it will work even if you do not customize the name. Now, if you want to customize the naming convention of the return type, you can use the return target for the attributes, and that's how that looks. Okay, so let's move on from service contracts. That's pretty straightforward, and get into complex types. And so there are several ways that we can introduce into the operations parameters and return values that can be included. Essentially, they need to be serializable as part of messaging. And so we have a couple of options. We have your basic serializable type, which we're used to using in the past with .NET Remoting, for example. And then we've got our data contracts, which are actually the way WCF prefers to expose complex types. And then we have the issue of how do I handle polymorphic types, where I might want to use a base type that has possibly several representations that are derived, and I can do that using something called known types. And then we've got the issue where we've got a schema granted to us, possibly, or data types that we cannot make serializable, and I just want to control serialization, and I can do that with iXML serializable. So I'm going to go through each of these things now. Starting with just how do we serialize with WCF? So I create this service contract, I define these operations, there are parameters and return types, and that ultimately gets
generated into a WSDL document to describe what messages should look like. Now, a message that comes into an operation will carry possibly one or more types that are represented by a schema in the WSDL. So for example, a complex type will be represented by a schema in the WSDL and associated with a particular parameter as part of a message. Now, the way that works is the data contract serializer in WCF, which is the default serialization mechanism, will look at the XML incoming and say, how do I map that to a CLR type, and what CLR type should I be building, by looking at your service contract. And it can handle data contracts, which are WCF things, serializable types, which are, again, a lot of serializable types that are built into the framework that we might want to share and expose, and then IXML serializable types, which I'll show you later. So in other words, the data contract serializer knows how to handle those three types, and therefore these are the three types of things we can put into the parameters or return values of a service operation. Starting with the serializable type. So yes, you may have the need to just include in your service contract any serializable type that you already have existing in either your application that you've created as custom serializable types and or things that are part of the .NET framework. So these will work. And that means any type with the serializable attribute. So it looks something like this, applied to the link item that I talked about earlier. That will work. What that means is that all of your fields, whether they're private, public, protected, will be included in serialization. You have no control over which things will serialize. They will all serialize. You have no control over the order of serialization because by default that will be alphabetical order according to the data contract serializer. And so if you don't care how it looks on the wire, this works just fine. So for example, TCP services that I am using behind the firewall, and I just want to get CLR type A across the wire to be reconstituted on the other end, then this will work. When we care about interoperability, however, we care a little bit more about naming conventions and usually what things we opt in. According to service-oriented architecture tenets, we should be able to control explicitly what things get serialized on the wire. And so that's where data contracts come in. So a data contract is a WCF thing that allows us to, in SOA nature, opt in what types we include in serialization and what elements of that type we include. So the data contract attribute gets applied to a type, and that allows you to map the type to schema. So the WSDL contract will generate a schema for your types that are marked with the data contract attribute. And then you have to opt in every member. So similar to where the service contract has operation contract attribute for every method, the data contract has data member attribute for every member you want to include in serialization, and you can apply it to a field or a property. You should pick one or the other, either apply it always to fields or always to properties, and we'll talk about that in a moment. So this is the preferred way to build serializable types into your service contracts, is to use the data contract. So let me just show you an example of that, and then we'll talk about some details that are applicable. So I have a different illustration here we'll just move over to. And let's start with the type that we're going to include in serialization. Here is my link item. Okay, again, it's a reference to a URL or some download with a date. So for example, if it's an event that I'm putting on, it might have a start and end date for a conference, or it could just have a start date for a date of an event. And it can have a title and a description. So these are the properties, these are the values we store for a link item. But notice that the property accessors do not have any decoration, neither does the type. Now, I would like to expose this in my Gig Manager service. So in this case, the actual link item is going to hold on to information for a band. So it's going to be a link to one of the gigs that they're playing. So again, it's just one of those versatile types. So I'm showing save gig receiving a link item and get gig returning a link item. And I'm actually using a per-mand caching here with the session. So I'm just holding on to that as part of a session with the client for now, not a database. The point is, this service contract will not compile. So I'm going to go ahead and try and build this. And because the link item is not serializable, I can't include it in serialization. So what happens is, I'm sorry, I said not compile, but what I meant was it won't host, is that when I try to host the service host will not like my contract. So we'll go ahead and run the service host. And I should get an exception any second here that will illustrate the reason. Unfortunately, this is one of those cases where the exception is usually valid, so let's or helps you find the problem. So it cannot be serialized, it says. Consider marking it with the data contract attribute. So isn't that nice? It actually tells us what to do. We don't get that all the time, right? So you have to enjoy these moments. So let's go ahead and move over to the link item and make it serializable. So how would I do that? Well, first of all, I would apply the data contract attribute. And so that's the first step. And that's actually part of system runtime serialization. And then I would have to opt in which of these members, data member attributes, do I want to include in serialization. So by default, if I wanted to, I could just apply this to all the fields. But what that means is that the naming convention is going to include the field naming convention. So that might not be preferable. There's ways to control that by using attributes of the data member. So for example, I could set explicitly the name, the order, whether or not it's required, for example. So what I'm going to do instead is I'll just apply it to the properties. So I'm going to get rid of these, and we'll scroll down and apply it to the actual properties, and then that will give me that formal naming convention. So that's an easy way to do it without having to set all those other properties, but I'll talk about reasons you might do that in the future anyway. And now I'll build my content types, so that's going to give us an updated DLL there. And we'll go ahead and get rid of that extra app config. So what I'm going to end up doing is generating a new service contract or proxy for the client. So we'll go ahead and build the host again. And we'll run the host. Now with metadata exchange enabled, I should be able to browse to that at whatever port I exposed. So I'll go ahead and go to 8000, which is what I usually use for the first service. So this is a HTTP 8000 metadata exchange endpoint. And this will allow me to browse to the Gig Manager service and all of its type information. So if we actually scroll down here, we can see this has a single port or endpoint. And if we take a look up here a little bit, what you're going to see is the list of operations that are available. So we've got Save Gig. It's also got a nested WSDL, however. And what this is going to show us, so when WCF generates the WSDL contract, it doesn't put everything into the first file. So we have to drill down a little bit. It's still the same difference because it's an import, but we need to drill down a little bit if we want to find the type information. And what we're looking for here is the link item type. And where that's going to be is in the namespace of schemasdatacontract.org content types. Why? Because that's the default namespace assigned to your schema. So if we take a look at that, we'll see the link item type has been defined indeed, but it's just not in a namespace that maybe I might prefer. And what you'll see here is that the order of the elements is alphabetical. It's indeed using the proper name of my property, so that's okay. And so this is what's going to be used by the client when we generate the proxy. We're going to see a type that represents that. So I'm going to go back to the application, and we'll go ahead and create a service reference for the client. And it's going to end up actually generating for us not only a service contract that we can use to as a proxy, but it's also going to have a copy of the link item, isn't it, so that we can actually create a link item and actually pass it to a parameter and work with objects at the client. So that's what you'll see here, is that we have a localhost link item, which is more or less a copy of the link item type in that namespace. And we scroll down far enough, we're going to see the properties: date end, etc. So date start, description, ID, title, and URL. Right? Okay. And so the client, I have already written some code that will actually use the link item type. So I'm going to go ahead and stop debugging, and I'll rebuild the client. We'll make sure we have all our references in place, and away we go. So when I run this now, it'll run the host and the client, and we'll get to test it out. I'm going to throw a breakpoint in the client too, so that we can see how that feels to the client to use this proxy. Okay, so this is going to, I've just got some stuff hard-coded in here as an entry for a gig, for a release party for a band. And here we go. We're going to create an instance of a link item type and set all of its properties at the client. The point is that when I get to save gig, it just feels like you're working with the service contract because we've generated a copy of all of the appropriate metadata. So what we receive at service is a reconstituted link item, which means that the transfer worked and that we're compatible. And when I go to get a link item back, I'll just make some junk in here and call get, then we're returning the same link item because I've held it in memory as part of the session. And at the client, of course, it will receive it properly, which is why we received the proper data back. Okay, so the point there is that when we use data contracts, we are able to include those types in the service contract. Just like serializable types, the distinction being that I can control which elements are included in serialization, and the distinction being that I can also control order and other elements. So let's talk a little bit about the details here. So the first thing we want to think about is that with a data contract, we want to make sure we provide a namespace. And the namespace should be similar to how you use the conventions for your services. So what I usually do is I use the web service standards for that. I use a domain, some category, a month, and a year. And then for my actual types, I use schemas.that domain. And again, it gives me a way to version the type later. The other thing that you can do is, like I mentioned before, being explicit with the name of the type can be useful in case developers refactor this business CLR type, then it won't break serialization. The data member attribute you apply either to fields, as shown here, or to properties, as shown here. Now, which way you prefer to go is really up to you, but remember that it should be consistent so it's not confusing to developers. And sometimes properties don't have storage, so if you apply them always to the property accessor, and if you have a pattern of implementing for all types, private, protected, and public property accessors, then you'd be all set. So I prefer to do it with the properties. But then I still can be explicit with the name. You should be explicit with if it's required or not, because then there's no confusion over what elements are required going out the door. And of course, anything you make required, never remove. We'll talk about versioning in the next webcast. And then order can be important too, because if you have several, 20, 30 members, it might look a bit strange if the ID is in the center and then first and last name aren't even in the same order when you look at the schema. Partners that do business with you externally might think that that's a bit chaotic, so it is always a good idea to provide explicit order in order to have a more formal contract. Now, if we applied to the fields, we would have ended up with this, as I showed you in the WSDL document. We would have M_ as the naming convention, and we would have alphabetical order. But if we apply it to properties, and more importantly, if we supply a specific name, a required or not value, and an order, so order equals 3201 in this case, then what we end up with is a schema that looks more like this, where we can see the schema presents better. Again, it's going to serialize in either case. It's just a matter of, for web services, we usually like to look more professional. Okay, so let's move on to something else. So far what I've talked about is some details about the service contracts and how we can serialize both serializable types, which we have no control over what goes, and data contracts, which gives us full control, and some best practices there. Now, along with that, data contracts also give us some other feature, which is that we can do this thing called known types. We can have polymorphic behavior and expose a base type in a contract that could receive any number of other types that are related to that type. And so it's called known types. What happens is you indicate what are the derived types or known types that are associated maybe with a particular base type. So you can actually associate a known type with a base type, and that way every contract that includes that base type will also support those known types. You can also specify it at the service operation or on the overall service contract if you would prefer not to globally state which known types are acceptable in each contract. So I'll show you a couple of examples there. The way it works is, imagine I have a link item, which we've been talking about, and sometimes it's an MP3 link, sometimes it's a photo, and sometimes it's a gig info. So maybe how we distinguish that is that in the implementation of the class there could be other features we pass, other members. And so the base link item class associates those three known types, and then each of these data contracts can now be serialized by clients sending to the service and vice versa, because just by exposing the link item in the service contract, the known types will also be included. So let me give you an illustration of that. I'm going to go share again and show you a different example. So here is a link item, and right now the link item does not have the known types enabled, okay? But the link item is indeed a base type that is used by several of these other types here. So we've got a gig info that inherits link item, we've got an MP3 link that inherits link item, and we've got a photo link, right? And they're all data contracts using the correct schema. Now in my service contract, Gig Manager, right now what we've got is an interface that exposes link item in both directions. Now without known types, what's going to happen is the WSDL contract knows nothing about those other types. It only knows about link item. And so clients might attempt to send one of these other derived types if they know about them from some other mechanism. So let's go ahead and just put a breakpoint in here. And I'm going to throw a breakpoint here, and we'll go ahead and just run the client and the service. So again, the service right now only knows how to deserialize link item types when we receive a call to save or get gig. So even though gig info is related, when we call save here, we're actually creating an instance of a gig info item. Okay, so we'll just skip over that stuff. It's just because I didn't recompile the client. And it's probably fighting to get to that breakpoint. Or not. Okay, I'll just stop debugging and recompile it all. If you don't recompile the project or solution, then it is thinking that the file is elsewhere, right? So to hit my breakpoint. Okay. So rebuild all, run it again. And again, the client's going to try and create an instance of a type that inherits link item because it somehow knows about it. We'll talk about how that might happen separately. So I create an instance of a gig info, which inherits link item. And that means that the XML element that gets serialized is probably going to say gig info. And so what's happening is when we call save gig, the data contract serializer is going to try to deserialize a gig info and say, I don't know anything about that, and therefore it will throw. So we'll take a second here and we'll see an exception at some point. The formatter threw an exception trying to deserialize, right? And scroll down far enough, it says it doesn't know about that type that maps to a link item. And it says, you know, consider using the known type attribute. So that's kind of useful. Now, what we need is for the service to respect gig info as an acceptable type. And again, you can stack these so that if you want to associate all the related types to a link item, then you can do so this way. And that means anywhere I use a link item in any service contract, by the way, all those types will be allowed. And that may not be the desired effect because in this case, clearly I only want to receive a gig, not a photo or an MP3 link. So it's something to think about whether or not you want to apply known types to the actual types for control. But nonetheless, let's go ahead and rebuild and at least see that that fixes our problem. Now, there's a couple of things that happen while this is loading up. What happens is because the known types are associated with the link item, that WSDL document will now not only create a schema for the link item, but it will also create a schema for the gig info, the photo link, and also the MP3 link. And it will also preserve the hierarchy because schema knows hierarchy. And that is how the data contract serializer and also the proxy generator knows to generate types and inheritance. So in fact, how I generated the proxy for this client, which includes the link item and the gig info, as you'll see here. So link item, MP3 link, photo link, etc., gig info somewhere in there. You'll notice it inherits. And that's because it's preserved by the schema. So when I run this now, we won't get an exception. And when we call get, we'll get the right data back. Because now in both directions, both sides, the data contract serializer knows about the type. Another important thing to point out is that the proxy also uses the known types attribute, by the way. So let's go ahead and look at that contract for the service. So the Gig Manager service contract, you'll see somewhere in here we're going to see a known types attribute. And there it is. So we've got the known types associated with the link item. Okay? Alrighty. Now, there's a couple of other ways we can handle this. You saw in this particular example that I was able to apply known types to the actual type itself. But that would mean every service contract supports link item as either gig info, photo link, or MP3 link. Now clearly we may not want that desired effect if we have different services using the base type. And so what we might want to do is cross out photo link and MP3 link in this case, because really only gig info applies. And so this would allow us to do that if we, instead of applying to the type itself with the known type attributes, we apply the service known type to the actual service contract. And you can be even more explicit and apply it specifically to operations in case there's differences. And lastly, if you're not sure about the types or you need to add types dynamically after deploying, then you can declaratively do this in the data contract serializer section of system runtime serialization. So my examples that you'll be able to download show how to do all of these different things. The point being, this is a lot like the first example I showed you. We associate to the link item the known types we support, gig info, MP3 link, and photo link. Okay? So this is a way to do that. And if we wanted to get into advanced, just so you know, there is a mechanism whereby you can dynamically insert known types to the data contract serializer as well. So if you had to be dynamic, then you could. Okay, so where do we leave off here then? We talked about serializable types, data contracts, and now known types, which only apply to data contracts, and the fact that you can have polymorphic behavior. But all of these approaches assume something here. They assume that you are able to generate your serializable types from your business objects or entities that you use downstream. And that is ideal in the sense that it's easy, right? We're used to creating types and making them serializable and having that generate for us a WSDL document or contract that has the schema so that clients can generate code to call you interoperably, right? And so in a perfect world, we're able to do that. We're able to create data contracts or serializable types out of our business entities and just use those things in the service so that when we receive a message, it constitutes our business objects for us, and we just pass them downstream to the business components and do the work. But in reality, you may not always own your business objects, so you may not be able to make them serializable. There's another option, too. You may need to support pre-existing schema. And in that case, you need another option. And one option that's really helpful for this is the iXML serializable type. And what that does is it actually gives you a way to say, respect a schema. Let's say you were granted a schema from a standards body. For example, Accord in the insurance industry has a whole number of schemas that represent policies and certificates and forms. And so you could take that schema from the industry and you could say, look, I'd like to expose this as a parameter, if you will, to my service operation, but I don't want to reverse engineer that into objects automatically because it's going to look nasty, because some of those schemas are very hierarchical and not easy to work with, and they certainly don't look anything like your business entities. Never mind that you might not want to use every element that is passed when you're integrating with partners. So, to comply with the partner schema, you use an iXML serializable type. You say, this is the schema I'm respecting for this type, but please pass me the XML so that I can control how we map between XML and entities. So this has a downside, and that is you have to understand the XML well enough to do that mapping. But the good thing is that it's less overhead than maybe having an interim set of data contracts that we don't like, that we then map to real business entities. So those are really your options. Now, when you implement iXML serializable, what you're doing is you're hooking the serialization process and saying, here is the the schema. So I'm going to provide a schema from the getSchema function, and I'll show you when that's called. And then, as we deserialize, we are passed XML to the readXML function of the type, and we are given an opportunity to read that bag of XML and turn it into objects before the service operation is called. And likewise, before we return data from the service operation, we are given an opportunity to write the XML. So it's probably easier if I just show you how it works. So let's take a look at an example. Okay, so iXML serializable types here is an example of a link item which is not serializable and not a data contract. And let's just assume that this either came from an ORM where I don't have control of the types to make them serializable, or perhaps pre-existing assemblies and whatnot. Or the other option, which is I have a really complex schema that I need to enforce, and it certainly doesn't look like my business types, so I don't need to make them serializable. What I want to do, though, is create the link item at the appropriate time. So let's take a look at the service. What I would have liked to do is say, hey, just expose this link item, right? But that's the thing I can't do. So instead what I do is I create a link item serializer. And that serializer implements the interface. So let's go ahead to the top of this file, iXML serializable. And iXML serializable has a getSchema function, a read, and a write XML. Now, I'll show you when read and write XML are called, because that's pretty straightforward. But getSchema is actually throwing an exception here because we're not going to use it. Why? because we don't really want to, when they're producing the WSDL, have to create an instance of this XML serializable type just to return a schema to you. And so an optimization that .NET 2.0 provided, because by the way, this is not a WCF thing, this is a .NET thing, .NET 2 gave us the XML schema provider attribute, which allowed us to provide a static method of your choice, so I'm going to call it getSchema, that would be called when the schema is being requested to generate a WSDL, for example. So here's what's going to happen. GetSchema is going to be called, and you're going to see it's called when the host loads the service and generates the service description. So let me go ahead and just run this, and you'll see each of these points being hit. And so as the host loads, we'll hit the breakpoint. Notice it's saying, get me the schema, and I'm just simply returning the schema. It's small enough that I just have it hard-coded here inside the code, but I could load and cache that from a file. Anyways, this is going to be called to generate the WSDL document so that I could now browse to it, for example. Essentially what it's done is it's created a service description that the data contract serializer can work with when we receive messages. So on the client side, when I call save now, what's going to happen is on the client, I'm creating a link item and doing my thing, but what I receive is an XML reader, which allows me to now take this XML and generate a link item. So notice the reader is just going to go ahead and read each element in the order I expect it, so I'm actually enforcing schema in the process. As I go through these breakpoints, you're probably going to see we're going to time out and I'll have to run through it again, but you'll see I'm looking for each element in the order that it should appear. And now the actual save gig function is being called, which you can see it's passed in the link item that I generated. And we continue. Now I probably timed out on the client possibly. Oh, maybe not. Okay. Now when we call to get the link item back, what's going to happen is we first have to provide the link item to, we have to return a link item serializer type essentially. So we're providing, I have constructed the link item serializer with the real link item business object, if you will, and it's going to be saved and passed to the runtime, which is then going to call write.xml at some point. And now I've already got access to the actual link item I want to serialize, as you can see here. And so we're just going to write each value out, and at the end, that will be serialized into the correct location of the message body so that we get the data back. Okay, so recap. iXML serializable lets me produce the schema I'm complying to, so it's included in the WSDL in the right location, and allows me to have control over serialization, deserialization. So that gives us our contract first approach, if you will, where I'm given a actual schema or WSDL to follow, but yet I still have my own types I want to work with. The other mechanism, which is easier, of course, is I just start with data contracts, and that produces a WSDL. But in either direction, there's always a WSDL in the middle, because the thing the client needs to do is generate proxies without having to call us up and say, what do the business objects look like, right? So that's what we're looking for. Okay. So I'm coming back to the slides here. It's just taking a second, it looks like. And It looks like live meeting is reconnecting here. So maybe I'll answer a couple of questions in the meantime. Okay, so question here. So an endpoint is where the operation of a contract is available, describing the protocol port, etc. Correct. Okay, I think what you're asking is, what is an endpoint? So an endpoint says, here's the address, here's the set of operations defined by the service contract, and here is the protocols that you can use to access that. Okay, I'm not sure if anybody can hear me anymore.
Yep, we can.
Okay, can you see my live meeting? Because I'm not seeing it anymore. I'm not appearing to be connected to the internet anymore or something. Can you?
Yeah, we're currently on the agenda slide.
Yeah.
The slide after your sharing slide.
Okay, so I'm not seeing anything. So
Okay.
I've lost my connection. If you can just hang on for a second.
Okay.
I know we're going long, but that's also because we had that technical issue before with the phone. So
Yep, no worries.
okay, so maybe if everybody can just hang tight, I should be able to reconnect this. Yeah. It seems like my wireless is just not available right now.
Do you have the hard copy, correct?
Of my slides?
Yeah.
Yeah. Okay, so I was trying to get back to my slides there. Sorry. I guess there was a bit of a technical issue with my internet here. What we're going to do now is sort of recap where we left off, and that is if I'm working with, building a service, well, when I'm working with service contracts, essentially I have my serializable types, my data contracts, which is code-first approach, and then I've got my IXML serializable types, which will help me do the contract-first approach in a little bit easier way. Another alternative would have been take a schema, reverse engineer it into data contracts, but that can sometimes be really nasty if the schema is quite big and messy. So just take a look at the schema first and decide if that's acceptable. And that would potentially allow you to use those types as your business entities if you don't have them yet, or allow you to map from the data contract to the real business entity, which carries a bit of extra overhead, but if the simplicity is more important and performance is not an issue, then that would be a way to go that is easier for developers than working with the XML directly. Now, one last thing we're going to talk about here on message contracts is there are times you might want to have access to the actual message itself. So remember that a SOAP message has headers and also a body. And what we've been dealing with in the service contract is really just the body of the message. So the parameters we pass in become parts of the body. The return value becomes a part of the body. But there's no way to access or create custom headers, for example, in an easy way unless you perhaps use a message contract. So what a message contract really gives you is the ability to have more control over the entire SOAP message. And so it's a bit of an advanced feature, but I'd say the number one reason you'll do this is if you're going to use custom headers. And so the attributes that we apply is we use the message contract attribute and apply that to a class or a type. And then inside we create one or more message headers and one or more body elements. And the body elements actually just are acting like the return value or the parameters you would have seen coming in and out of the service contract. And so these are useful for a couple things. Number one use would be custom headers, very easy. The other would be to maybe turn on and off wrapping of a message, which is really related to that extra XML element that goes around the message that some Java platforms, for example, turn off by default. So for interoperability, that can be helpful. And then another thing could be if you don't want to encrypt and sign the whole message, but there's a certain piece of it that you'd like to encrypt, it can improve performance if you don't encrypt the whole thing, if it's not all requiring that level of security. And the only way to do that, again, is to use these message contracts. So next slide. So the message contract attribute then converts a SOAP message or a type to a SOAP message and vice versa. And I already mentioned that you can set the is-wrapped or protection level properties. You may also want to set the name and namespace, but those are inferred from the type name and from the namespace of the service contract. So normally we wouldn't have to set the namespace here unless you want to have different namespaces for message parts. Now what you see is that the message contract has is-wrapped set to true and protection level sign turned on. What that means is that in this example, the save link request type, which is presumably the message that comes in when we call save link, is going to receive a message that is signed but not encrypted. And by default, it's usually signed and encrypted. And then again, the save link response is a message contract as well with no particular declarations on it. So in the next slide, the message header attribute is something you can place inside that message contract and apply to specific fields or properties. So just like with the data contract, we've got either fields or property level application to opt in a header. And for a header, you may provide a name and a namespace if you have want to customize explicitly the namespace for each header. You can also set the protection level, so some headers might be encrypted and signed and others just signed. And then you can also get deeper into the SOAP protocol if you are familiar with things like relay, actor, and must understand. Those are features that you can set on the header. The next slide talks about message body member attribute, which you apply to fields or properties that will be parts of the body of the message. Now, what's the body of the message? Well, when we receive parameters to a service operation, there might be 2 parameters. Those would be 2 body members. When we return from a service operation, there's only ever one return. It's whatever the complex type is you put. But if you use a message contract, you can return multiple types and organize them as message body members. And you should supply the order, and you can supply, again, custom namespaces and protection levels for each and every body element. So in the next slide, you'll see an example of what this looks like. And I do have a code sample that is part of the download I mentioned earlier that has this working. So what you see on the sample code here is a message contract that has wrapped turned on, which is the default, which says I'd like to sign the message but not sign and encrypt. And inside, you'll see a license key and a link item. The license key is a message header string, which is encrypted and signed. And the message body member is the link item, which represents a parameter to the operation. And so the message contract on save event response, in this case save event request and response are paired. The response has no members. That just means that it's like having a void return to the operation. Now in the next slide, what you'll see is how we apply that message contract then to the operation parameter or return. And so the service contract that you see here, iContent Manager Service, has a save link and a get link request and response. And the save link request and save link response paired are the ones I showed on the previous slide. And get link request and response might be similar. There may be a license key, there may not be a license key. Again, each request and response can decide if they require a particular header, custom header. The important thing to note is that you replace the idea of a serializable type or a data contract in the service operation signature with a message contract. And there can only be one, of course, because you can only have one message in and one message out. So typically, if you go with message contracts, you will define a message contract for the parameter and for the return type of each paired request and response. And I would recommend that if you're going this route, you do it for all operations on the contract so that it's not confusing to developers. That would just be a standard that you adopt. And typically, when you require headers like a license key, well, you might require that to most operations on that contract anyway. So on the next slide, you'll see how we apply this in terms of when we generate a proxy at the client. What's going to happen is the custom header, which was defined in the WSDL document, becomes a parameter to the SaveLink call. So even though SaveLink only really receives one body element, which is the link item itself, you'll see here that the m_proxy.SaveLink call receives the first parameter, which is the license key. And then that license key can be processed, as shown on the next slide, when the service contract, the implementation of the operation, receives its request. What we are past is the message contract. So we're not past the individual header and body elements. We're past the message contract. And it has a property for the license key and a property for one or more body elements that you provided. And so you just access those as members directly and do your thing. Okay, so with that, let's just skip over to the last agenda slide. And that agenda slide just really, leads us to a summary of everything we've talked about. So if we go to the WCF contract summary slide, the next slide, what we've talked about so far today, and there is a continuation on contracts in 2 days, is the fact that in a service contract, we certainly can use either serializable types or data contracts as part of the parameters or returns, that we can do contract first approach with IXML serializable as a helper for that, and we can do code first approach, which prefers the data contract instead of serializable types. Good to know that your serializable types can be serialized. And then if we want more control over the SOAP message, and perhaps for custom headers specifically, we would use a message contract instead of serializable types in the parameter and return. And then lastly, in all of these aspects, one of the things I've sort of mentioned is that it is a sort of a decision that you should make and be consistent with whether or not you are very explicit in you defining all of your contracts so that you always have the name and the namespace and the action and reply action and all of those other things that we talked about with service contracts and data contracts and message contracts. Having specific defined elements in each of these attributes simply helps developers know what's really going on and what would affect the WSDL document. Because remember, any changes to CLR types that are part of the contract will change the WSDL document and could impact existing clients. And that's sort of a segue to what we're going to talk about on Wednesday morning, which is related to versioning of contracts. So with that, if we go to the more information slide, just remember that on my blog I typically will post content additional to other presentations I do and such, so at dosblond.net. And on the iDesign site we have a number of advanced samples that you might enjoy on WCF that are posted there, so iDesign.net. And for my book, Learning WCF, all of the code is posted to thatindigogirl.com, currently in C#, shortly to VVB. And I guess with that, I'll just wrap up today and take a look if there are any questions that I can answer.
All right, thanks, Michelle. I'll go ahead and take it from here. So as Michelle mentioned, we're going to go ahead and do a quick question-answer summary session. So she will go ahead and answer some of your questions verbally, and for the rest that we don't have time, she can just go ahead and stay online and reply to your questions via text. We're also going to be doing a survey. I'm going to go ahead and put the survey up there in just a moment. So just go ahead and complete that survey for us. Your feedback and comments create better webcasts for you. So simply click on the links provided in your interface, fill that out. It should take only a minute or two, and I'll go ahead and hand it back over to Michelle to start answering questions.
Actually, I won't be able to see the questions because I'm still not connected to the Internet. There's a problem.
Okay. Do you want me to go ahead and read a couple of them? Or how do you want to do that?
I suppose that's the way to go.
Okay. The first question is there a way we can verify a service created in WCF is BP compliant?
If it's what compliant?
BP compliant? B as in boy, P as in Paul?
If it's BP compliant. I'm not sure I'm following that. I don't really know what that means.
Okay, whoever wrote that question, if you can go ahead and maybe elaborate on
Oh,
that.
basic profile. Sorry. Yeah. I don't usually use an acronym for that one. Okay. So basic profile compliant, is there a way to check that it is? Well, you actually know that it is if you're using basic HTTP binding. That, by default, is basic profile compliant, and if you use WS HTTP binding, then you are not basic profile compliant because you're using the advanced standards beyond what's in basic profile. In terms of can you do a validation, WCF doesn't have a built-in validation for basic profile compliance. It's just the binding you choose.
Okay. Okay, the next one is it possible for a linked item to have a collection of linked items as its property?
Sure, why not? You can have collections, you can have complex types that have arrays or collections of nested complex types that have other arrays and collections of nested complex types. The depth to which you can go is controlled. There are some quotas for how deep the XML nesting can go. That's for security reasons, so you may need to pump that up if you have a hierarchy that is quite deep.
Okay, and then
We'll talk about that in bindings, by the way, so when I get to the bindings webcast.
Okay, and the next one is, can I put a username and password in a message header?
Absolutely, but you wouldn't want to create a custom message header for that because that's built in. There are security standards out there by OASIS, WS Security, that supply us with a standards-based mechanism for passing a username and password. So we would just use that. And I'll talk about those things when I get to the security webcast.
Okay, well, it's about 10:30, so I think we've got a couple questions left, but does it work for those people to just email you?
Sure, no problem.
Okay, so yeah, if there's any questions left that we haven't gotten to since we have got about a half hour over time, just go ahead and email them to Michelle. And thanks again for attending this live webcast. Thanks for your patience during the tech issues. And thanks to Michelle for a great webcast. All right, and that concludes the audio portion of this webcast.